All right, for the sake of time, we will go ahead and get started. Good morning, good afternoon, depending on where in the world you're joining us from. My name is Brooke Ruprecht, and I'm a consultant at the German-American Chamber of Commerce of the Midwest, located in our Detroit office. And on behalf of GACC Midwest in Detroit and Chicago, as well as our colleagues at GACC South in Atlanta, I would like to warmly welcome you all to our second part German Online Lightweight Symposium of our metal material focus. This event is a continued discussion from our first part one symposium earlier this week on Tuesday, at which we focused on the use of composite materials. Today, we'll hear from German and US experts to understand the latest trends and obstacles for the processing and use of lightweight metals in the automotive and aerospace sectors. Just first, a couple of housekeeping rules. If everybody could mute themselves to start, this will help avoid background noise and distractions to our speakers. In addition, you'll see my colleague who is GACC Midwest today online. If you are experiencing any technical difficulties, please use the chat function to coordinate with this tool. And my colleague Francie will do the best to support you to resolve those issues. In addition, for those who aren't familiar with the Zoom platform, in the top right-hand corner, you will see a view button. You can change this view into speaker view or gallery view. Gallery view allows you to see all attendees online, hopefully bridging that virtual gap that we're all feeling right now, making it more of a communal event. However, when we do go into speakers in our panel discussion, it will likely be easier to follow who is speaking by switching to speaker view. If you do have any questions throughout this event, please feel free to put them in the chat box and we will address them at the end of the presentations, in addition at the end of the symposium. And I also would like to address you to our delegation brochure. You should have all received an email from me yesterday if you registered prior to 5 p.m. With a link to our delegation brochure. In this brochure includes the company profiles of all of 11 of our delegates, as well as the agendas and bios of our speakers today. If you haven't seen this email, you can also find that delegation brochure online at our website, German-American or GACCMidwest.org, on our event page, 1029 event. So for those of you who do not know us yet, the German-American Chambers of Commerce are the official representative of German industry and trade in the US. The 4 chambers in the US, Atlanta, New York, Chicago, and San Francisco, are part of a network of 140 chambers abroad in 92 countries around the globe. The event and entire business delegation was made possible by the Foreign Market Entry Program of the German Federal Ministry of Economic Affairs and Energy. With this program, the Federal Ministry supports German companies in the pursuit of positioning themselves in foreign markets. For example, through events like this one, where the companies can utilize the opportunity to learn from and connect with experts and present their own products and technologies. So this symposium this morning is a prime example of Germany's economic powerhouse, as well as the country's strength within this industry. Today, you'll hear about innovation, technology, and collaboration happening from both sides of the Atlantic to contribute to the development and advancement within the metals industry. The importance of this industry cannot be ignored, as we will learn today. Specifically within the automotive industry, it has predicted the use of lightweight metals such as advanced high-strength steels, aluminum, and magnesium will increase in the coming years. In addition, high-strength steels allow a weight reduction of up to 25% and are stronger and more formable than conventional steel at a comparably lower cost. I would like to express special thanks to IACME and Ford Engineering North America for promoting the delegation and for connecting us to our excellent speakers today and throughout this delegation week. Thank you, Adam, Dale, and Ray, and the rest of your team for the fantastic support. I would also like to thank our promotional partners at the American Composite Manufacturers Association, the Detroit Regional Partnership, the Michigan Economic Development Corporation, and The Right Place for sharing our event to your network in Michigan and through all of the US. Lastly, a big thank you to all of our US speakers and moderators at both events. Without you and your support, this would not have been as big of a success, so thank you. We are so glad you all could join us today, and we are looking forward to an exciting and engaging discussion. Without further ado, it is my pleasure to hand over the screen to Mr. Werner Loscheider. Mr. Loscheider has been head of Division IVB4 for construction industry, lightweight construction, new materials resource efficiency since 2014 in the Department of Industrial Policy at the Federal Ministry of Economic Affairs and Energy. Prior to this, he was head of the LA2 Political Coordination Division and head of Division IIA4 Tourism Policy at the Federal Ministry of Economic Affairs and Technology. Mr. Loscheider holds a diploma in agricultural engineering from Rheinisch Friedrich Wilhelms University. Mr. Loscheider, the floor is yours.
Thank you very much, and I hope you can hear me over there. And a very warm welcome from Berlin, from Germany. And it's a pleasure for me to have the opportunity to share a few thoughts with you. And I'm the head of the division for lightweighting, new materials, and resource efficiency in the Federal Ministry for Economic Affairs in Berlin. And my talk today is about two initiatives of our ministry. The first one is about the market entry program, and the second one is about the lightweighting initiative, and that will be the main part of my presentation today. So let's get started with the market entry program, and in a nutshell, that is a program mainly made for small and medium-sized enterprises and to support them doing business abroad, for example, as we do today here between Germany and the US. So, and it has a focus on selected market and related and SME-related issues. And what might be more important is that we are offering an intensive mentoring through experienced organizers. So that program consists of 5 modulus or 5 parts, and usually it gets started in Germany with an information event, and then you can find 3 other parts in the target markets. And the first one is about fact-finding, the fact-finding mission. The next one is initiating business opportunities, and the third one about showcase events. And there's another part of that program, again in Germany, and this one is about fact-finding visits for purchasers and multipliers. So in these Corona days, I guess the most important thing is, if necessary, and yes, it is necessary, it can be done virtually, and so that's a good opportunity for all of us. And if you have more interest, if you have more questions on that program, please feel free and get into contact with my colleagues in the 2 offices, and it will be a pleasure for them to help you and to give you the required information. So let's move on to the second part of my presentation. And now it's about lightweighting, the major part of the presentation. And of course, the Corona crisis is the overwhelming event for all of us in US, in Germany, all over the world. But there are still other global trends, global challenges we are facing, and we have to tackle, because they give us huge opportunities, especially regarding lightweighting. And lightweighting is for us a game changer technology, which is very important to set up sustainable growth. And we see lightweighting together with resource efficiency as enabler, as driver for innovation. But at the same time, lightweighting is a typical cross-cutting technology consisting of different industries, different materials, and different manufacturing processes. And how complex that structure, that technology is, can you find here on that slide with that wonderful bionic structure on honeycomb structure. That's as well typical for the lightweighting business. And so bringing all these different stakeholders together with the different backgrounds they bring in, that's not a self-fulfilling story or promise. That is hard work is needed to be done. And that's what we have done in the last years in our ministry, setting up that specific net in the field of lightweighting. And so we have established the lightweighting initiative. And this initiative of our ministry consists of quite a few elements, and I'm going to talk and going to introduce to you only the red colored elements. So the first element is the strategy group, and that body consists of different of representatives of the Länder-Lightweighting-Organizations, and there are 16, because in Germany we have 16 states, and they send one representative to Berlin, and so they bring in a lot of knowledge and experience in the field of lightweighting. And what is as well very important is that we have with these guys from the state level the opportunity to combine the federal and the state level, which is very important for us. On the other side, you find the representatives of industry, union, and associations, and they bring in knowledge and experience in the field of lightweighting, and they represent the different materials we use in the field of lightweighting, composites, steel, wood, aluminum, and all that is represented here. And so we have the chance to build up an idea of a hybrid, of a multi-material lightweight. Yes, of course, it is a broad and a complex structure, but typical for a cross-cutting industry. But what is more important is that we have a strong, solid base for our political work. And that is important, and that works very successfully, very well. So another element of that initiative is the lightweighting atlas, and that runs as well, because we have currently 700 companies, organizations using that digital tool, mainly from Germany, but more and more organizations and companies are from Europe, and even some are from abroad. So these companies use that tool to present their lightweighting skills, their lightweighting knowledge, and they hope to find business partners like today, even from abroad, and business partners, for example, from the US can find, of course, German business partners with that, the help of that tool. The next element is a very important one. It's the lightweighting strategy. And our goal is to create a strategy from the economy for the economy. And therefore, we have set up different elements, and we are involving about 350 experts from industry and research in that process, in that bottom-up process. And we have held 3 workshops and 1 final conference, and that runs very, very good, because we had at the first workshop around 300 experts from industry and from research taking actively part in that work. And so we generate a lot of information and incentives, and actually more than 600 ideas and impulses, and 42 very specific actions. And we have put that all together in a paper of key issues you find at the right. And that is for us, that paper from business and research, that is for us the base for our work. And now we work on that as Ministry for Economic Affairs on our lightweighting strategy, and we will finish that by the end of this year. So let me add this. From our point of view, that process is a win-win process for us as ministry, because we have got the required information, the required knowledge in the field of lightweighting, and on the other side, we have offered to the to business and to research the unique opportunity to shape their own lightweighting framework. The next element is, from my perspective, a milestone. It is a technology transfer program for lightweighting, a milestone because it is for the first time that we have in Germany a funding program only made for lightweighting and new materials, and on a very solid, on a very strong financial base of 60 up to 70 million euros per year. And there are 5 goals which are important for us. The first one is to bring lightweighting in a broader industrial application. The next one is about innovation and value creation potentials. The third one is to support cross-industry and cross-material knowledge and technology transfer, typical for such a program. And the fourth one is setting up fully digitized and linked value chains. The last one is an important political goal, the contribution to achieving the sustainability and climate goals. So how do we achieve these goals? Therefore, we have set up 5 funding lines, and which you can find here. And the important thing about the financing is that we get the money out of 2 different financial sources. The first one is, not surprisingly, is the budget of our ministry, and there comes 4 million euros per year, and that money goes into funding line 1, which is about technology development. But the lion's share of the money comes from a second financial source, which is the Climate and Energy Fund of the government. And that money goes into funding lines 2 and 3, CO2 savings and resource efficiency. And we're talking here about 60 up to 70 million euros per year. And that shows, because the money comes from the climate fund, that shows how important climate protection generally is already, and how important climate protection is for lightweighting and specifically for the funding of that program. There are 2 other important funding lines you can find here, for demonstration projects and standardizations. There is no additional money available for that, but they have to be able to assign to the funding lines 1, 2, and 3. So, who can be funded? Yes, more or less anybody who has a permanent establishment or branch in Germany. So it is open for companies, universities, and non-profit organizations with a permanent establishment in Germany, and they can be funded for individual and collaborative projects. And if you like to join our funding program as American organization or as American company, it is open, it is possible. But if you have no permanent establishment here in Germany, you can't receive any funding from us. So let me sum it up in this way. That is a very, very successful and helpful funding instrument for us, and there's a huge demand for to get funded from that program, and so we are very happy to have that funding program. Yes, let's have a look on the international level, because lightweighting is an international challenge at the end of the day. So we have to improve our networking like we do today here on European and on international level. And the first initiative I want to introduce to you is the first meeting of the European Lightweighting Network. And that is an initiative of our ministry under the framework of the EU Council presidency of Germany at the 26th of November. And the idea is to bring together the different stakeholders from business, research, European Commission, and the different ministries in the member states in Europe responsible for lightweighting. And so we think that's a good idea to improve networking in Europe. The second event is a completely different one. It's again about networking in Europe, but it is a political event on high political level. So the second lightweight summit I'm talking about is on the 13th of April next year at the Hannover Fair, and one of the speakers will be our minister, Peter Altmaier, and there will be other minister, state secretaries, and high-level speaker from economy and research. So that is a political highlight you shouldn't miss. So again, on international level, the foreign market entry program, I have introduced it very briefly, and here is the goal to use that helpful instrument more and more to promote lightweighting. And as we do today with you guys from US, we want to do it is in a similar way with China, Israel, Netherlands, and Japan in the next weeks and months. So what could be a common German perspective? Again, the interesting part could be the market entry program, and there is another opportunity for you, which is about the fact-finding visits for American purchaser. It might be interesting for you. And the second idea I've brought with me is the lightweighting atlas. This tool is available in English. It is open for American companies and organizations, universities, or whatever. And it might be as well an opportunity for you to get connected with German or European companies, organizations. So please have a look at it, please use it, and please present your organization, your company within that lightweighting atlas. That's win-win for you and for German companies as well. And of course, the third point is improving networking on more or less every level, on government, company, cluster, research level. That's what we have to do continuously. So finally, let me sum it up. For us, lightweighting is a game changer technology that is important for improving, strengthening, modernizing our industrial sector in a sustainable way. And let me illustrate that with the lightweighting principle. That principle stands for less weight, less energy, lower emissions, greater functionality, and better resource efficiency. So that are the opportunities, but on the other hand, there are still some challenges we are facing. And the first one is, from my point of view, we have to establish fully digitized and connected value chains with the required lightweighting expertise on every level. The second one is about cost, reducing cost, especially for your sector, for the automotive sector, but that's important for every sector as well. The third one is setting up suitability for mass production, and the last one is establishing sophisticated recycling processes for, especially for multi-material lightweighting. That is important because we have to get and to secure the acceptance of society and politics, and so that environmental issue is important. And if we do so, and I'm pretty sure we will do so, then lightweighting is a win-win-win technology for jobs, climate, and companies. And if you have more questions or concerning the technology transfer program for lightweighting or concerning the lightweighting initiative, please get into contact with my colleagues. It's a pleasure for them to help you. And so thank you for having me, and thank you very much for your attention. All the best for you.
Thank you, Mr. Loscheider. Yeah, that was a takeaway on Tuesday's conference, and I think another takeaway today is that for our U.S. audience, there is this lightweighting atlas to, of course, promote your company in the U.S. as well as abroad and find those collaboration opportunities, which, we are also here today to do. So thank you for your words. If there are any questions about Mr. Loscheider's presentation, of course, feel free to drop them in the chat box. If they come up later, that's fine. We can also address them at a later point. But just to stay on track, I will introduce our next speaker, as I'm not seeing any questions come up right away. Next, we have Joe Steele he is the Director of Communications and Legislative Affairs at LIFT, Lightweight Innovations for Tomorrow. Joe is a veteran communications and public affairs leader with a track record of developing and executing successful plans, strategies, and delivering legislative victories, employee engagement, and building key stakeholder relationships for Fortune 500 companies, statewide political campaigns, nonprofits, and startups. As Director of Communications and Legislative Affairs at LIFT, Joe is responsible for building media and stakeholder relationships, as well as supporting the sales and marketing teams. Joe, the floor is yours.
Thank you. You can see my screen, correct?
Yes, we are good.
Fantastic. So thank you very much for the introduction. Again, my name is Joe Steele, the Director of Communications and Legislative Affairs for LIFT. It's interesting that I'm following Werner's presentation because there's going to be some similarities, I think, in the way that we operate and have viewed lightweighting over the years and where we're going into the future. So LIFT is one of 16 now National Manufacturing Innovation Institutes that has been set up in the United States. Similar to I think those that have been established in Germany years ago, the Fraunhofers. And I know you guys know IACME as well. So of these 16 institutes, 9 of them now have been sponsored by the US Department of Defense. And that is where LIFT stands. LIFT was founded by the US Department of Defense back in 2014. And we are a public-private partnership between the DoD, industry, and academia. Now we were founded, and we had gone by the name Lightweight Innovations for Tomorrow, but over the past few months, we have evolved. And I think the presentation by Werner was very interesting because he mentioned the fact that lightweighting is really a cross-cutting theme, and that's really how we've begun to view it. We focused our first 5 years on lightweighting specifically around metallics. But as we've grown, we understand that we really need to broaden our scope of work as it relates to innovation and carrying innovations from the lab to the marketplace. So we are evolving and growing and really connecting materials, processes, and systems along with the talent to drive rapid implementation of smarter manufacturing, because we believe that the next, economic powerhouse, we're obviously focused on the United States, will be, the area and region that is able to make that connection, that connection first. So we view it as solving the manufacturing equation, materials, processes, and systems, plus the talent required to make it all happen. We understand that we cannot have the technology without the talent to work on it and to drive it. We also understand that we can't have the talent there without the technology to work on. So we operate really in 2 different programs at LIFT. And the first is Leading Innovations for Tomorrow. That is our technology program in which we are taking technology innovations from, as I mentioned, from the lab concept to the marketplace, take it into industry and into the hands of our men and women in the military. We also have the Learning Innovations for Tomorrow, which is our talent side, where we're really trying to expose the future careers of advanced manufacturing, expose that sector to our students across the curricula, the continuum, from high school students, from K to 12 students, to folks that are looking to earn a certification, to our returning men and women from the military to support them as they transition back into a civilian career. So I mentioned that we focus on taking innovations from concept to production ready, and that's really where we live, the so-called valley of death between MRL4 and MRL7. We know that the materials, and there's a lot of investment in research that takes place on the 1 to 3 side, happens at universities, happens at national labs, things like that, and they get to a point where they've seen some success in the lab, but then the funding kind of dries out, and it doesn't come, it's not readily available again until it gets more ready for production into the marketplace. And so we are helping shepherd those innovations across that valley of death to really bridge the gap in manufacturing innovation. So we are there between 4 and 7. So I mentioned we are a public-private partnership, and much like Werner's presentation, we are a membership-based organization. We're obviously focused on the United States. So some of the things that he had said about German requirements, we have the same requirements as it relates to members in the US. You must either be based in the US to be a member, or have production facilities here in the US to become a LIFT member and receive some of the funding that we're able to flow down to get some of these projects underway. But in terms of what we do for our members, we are a trusted advisor. We're not playing favorites in terms of what technology or what we're recommending or how we work with our members. We have experts across the country in a variety of industries, both in-house and across our ecosystem. So we're going to try to provide the best advice that we can, the best direction that we can to help particularly small and medium-sized manufacturers move into that direction. I mentioned we're a talent developer. So we have a LIFT Learning Lab that is in our facility. So it's unique in that it's not in a school, it is not in a community college. It is perched above our high bay facility. So before the pandemic, and I hope everyone is safe and well and staying healthy throughout this pandemic. Before the pandemic hit, we had 120, 150 students going through our program through our LIFT Learning Lab. Whether it's the curriculum that we had developed through the Department of Defense called Ignite Mastering Manufacturing, where high school students were coming each and every day from a local Detroit high school to go through that curriculum and really learn about materials, learn about advanced manufacturing, from robotics to pneumatics and electronics, things like that, to bringing other groups through to earn certifications in welding or CNC, for example. So we're really trying to develop the next generation of manufacturing talent. A convener, I mean, frankly, that's what we're doing here today. So thank you to the German-American Chamber of Commerce for their invitation again. We have a national network of folks from the DoD to government to industry. We can help bring people together from across the country to help, and apparently today around the world to talk about smarter manufacturing. A technology showcase. Again, you may have seen earlier in the week, we share our facility with IACME, and our technology showcase really it crosses all kinds of materials. You have IACME focusing on the composite side. LIFT has been focusing on the metallic side, although we're expanding that now to where we can see the art of the possible and really see how those connections of materials, processes, and systems and talent really are made. And a word, connector, public-private partnership. As I mentioned, we want to bring the right ideas to the right people to make sure we move the needle and drive American manufacturing into the future. And finally, technology accelerator. We talked about that. We want to move those emerging technologies to commercialization as fast as we can. So I'll talk a little bit about the leading innovations for tomorrow. Again, this is our technology side of the house. Some of these I mentioned we're growing in terms of our scope of work and beyond just metallics, but a lot of this we had been working on all along, and starting with integrated computational materials engineering, the ICME. We really want to make sure that we know the material, whether it's metallics, whether it's composites, whether it's ceramics, whether it's something else. We want to make sure that we're able to characterize and know how the material is going to react before it goes through a manufacturing process. So we know that when we're connecting those materials to the process and eventually to the system, we know exactly what is going to happen. So we're working on various processes as it relates to that. Agile and smarter manufacturing. These are kind of new processes we are working on, whether it's wire arc additive manufacturing, where we're taking a welding arm and laying down different materials to machine into a piece of different kind of additive manufacturing, to smarter manufacturing, where we're connecting the digitization, as Werner mentioned earlier, making sure that the digital, we can watch the digital thread so we know that real-time optimization can happen. We can track that and improve in situ or as the process is going on. Advanced alloy and process development. This again goes back to our history in metallics. We want to make sure that we know what kind of alloys we're working with, what kind of processes they can undergo. We have a large extrusion press, and before the pandemic hit us, we were extruding magnesium just to see what we could do with it. And finally, again, back into our history, multi-material joining. How can we, as it relates to lightweighting, I mean, that's a lot of what people are dealing with. How do we join these materials in a way that they can be most effective? And a lot of times those materials don't want to get along, but we have ways to do that. So this gets a little bit deeper into some of the processes that we work on. It's a long chart, but we're happy to entertain any questions afterwards about this. And then finally, the learning innovations for tomorrow. Again, we want to make sure that the skills gap that exists in advanced manufacturing is not a Michigan problem. It's not a Detroit problem. It's not even a United States problem. We know that around the world, manufacturers are dealing with the need for talent with the right knowledge, skills, and abilities to work in advanced manufacturing. So that's why we developed the Ignite Mastering Manufacturing curriculum. That is, again, where I mentioned where high school students are able to go through and learn material science, introduction into advanced manufacturing, then move on into advanced manufacturing systems. The LIFT Learning Lab is really made up of 7 unique labs that we have in our facility, running from fundamental skills to smart factory to welding and CNC operations. We offer certification programs, as I mentioned, CNC and welding, soon to have robotics. And finally, Operation Next is a program that we had developed. This is very much US specific, but to help our active duty men and women in the military, as they get ready to leave the service, the last 6 months of their service, they're able to earn a certification. So it makes it easier for them to find a civilian job in advanced manufacturing. And frankly, as we go through the pandemic, we just announced earlier this week that we are taking this program out of the military and into industry for the first time to help small and medium-sized manufacturers, specifically starting here in Detroit and in Pittsburgh, to help those small and medium-sized manufacturers provide training opportunities for their workers, so those folks can get back off the ground when it comes to regaining from the pandemic. So I invite you to join us at LIFT. You can follow us on LinkedIn, follow us on Twitter, and see what we have going on. You can also visit our website at lift.technology. And I have about a few minutes left. I want to share one more thing with you. I want to share, give you a peek into our facility, which I think you guys have seen the IACME side of the house. I want to show you the LIFT side of the house really briefly, as soon as this loads up. This is our facility shared with our friends at IACME, and as I mentioned, we are really process driven here. But come to us in about a year, and we will show you a lot of new materials and new processes that are happening here, particularly in this middle area that we had left open specifically. We've got big plans for this area coming in here, but you'll see we have a large extrusion press down here in this area, working on things like incremental sheet forming, as I mentioned, smarter, agile manufacturing. Incremental sheet forming is certainly one of those where, instead of investing in a large forming press, couldn't we be more agile? Couldn't we be smarter by programming a robot to essentially make the shapes, make the pieces that we're looking for? So it program the robot over time, and it can form form a shape, form a piece. We do have a traditional forming press over here. You guys are probably familiar with forming presses, but I do want to show you two more things in the brief time I have left as I walk down our facility. Again, this area will be evolving. I want to show you, this is our robotic cell, which has 4 large robots, welding robots in there. But what we're using it for is wire arc additive manufacturing, as I mentioned. We want to see if we can't take additive and bring it into use with welding arms. So see the arm is laying down different beads of welds. We can then machine those down into a particular shape, and then we have a piece. But we're working on characterizing those now, working with our friends across the state and across the country on that. And finally, we talked about dissimilar materials. I want to show you, we have the continent's largest linear friction welder that is here, and really helpful in joining dissimilar materials. So what this machine is able to do is able to essentially use heat and friction to weld a piece together. It holds one piece of material steady, where it gently, imagine rubbing your hands together. You'll generate heat and friction. It'll generate that heat, and with 75 tons of pressure, we're able to weld them together. You see the one piece being entered in there, being put into place and cleaned up, and we'll have a weld coming up here very shortly. But very important in joining dissimilar materials and very strong welds. This is used in the aerospace industry, as you guys probably know. But we're proud to have this machine here at our facility, one of the only ones available for R&D purposes. And here's a weld coming up. And there you go. It doesn't take very long at all. So we invite you, if you're in Michigan, if you're in the Detroit area, please join us. We're when it's safe to do so, obviously. Again, if you have any questions, we'd be happy to entertain those. But in the meantime, I want to keep everyone on schedule, and I'll turn the floor back to Brooke.
Thank you, Joe. Yeah, I think your presentation really highlighted the support and network that LIFT can offer to drive advancement in the industry and really address those challenges. I actually do have a question from the audience for you. The question was, how best can upstream material technology and producer companies get involved with LIFT?
That is a great question. We have a variety of membership levels, so it really depends on the size of the company, where they operate. So I'd be happy to take that question offline. So I'd be happy to take that email, or if you can connect me, Brooke, that'd be great. We'd be happy to do that. But we have all the way from platinum levels to startup levels. So it really depends kind of where you are in your industry and what you're operating on, how large you are. So yeah. Happy to work with folks.
Yeah, it sounds like no matter where you are in the value chain, LIFT can offer some sort of support in your technology and advancement.
We want to make sure that the supply chain is robust and healthy, and that means connecting the large companies with the small companies, because innovation really happens at the small companies, and we like making those connections. So.
Mm-hmm. Understood. Thank you so much. Well, again, if anybody in the audience has questions, definitely feel free to drop them in the chat. And for the question that just came in, we can connect offline, Joe and that company, so that you can provide further information.
Thank you. Thank you, everybody.
To stay on track, next we'll move on to our panel with our 4 German delegates from APOS, Laubinger and Rickman, SCHULER, and WST. And this panel will be moderated by Adam Halsben. Adam is Managing Director of Forward Engineering North America, the North American division of Forward Engineering GmbH, a global design and engineering firm based in Munich, Germany that specializes in enabling cost-effective inclusion of fiber-reinforced composites in serial mass-produced automotive and mobility structures. Adam began his career at the GM Tarrytown, New York assembly plant, with the search for more capable means of high-value mixed material vehicle manufacturing, which has been central to his role throughout his career. As the managing director at Ford Engineering North America, Adam is able to leverage decades of experience working together with colleagues and customers to maximize quality, performance, and cost around some of the most challenging automated manufacturing applications. Adam, the floor is yours.
Thanks so much, Brooke. Can you hear me okay?
Yep, hearing great.
Excellent, excellent. So we're really real fortunate to have a diverse group of companies representing innovative technologies in this panel session. We have EPOS, Laubinger-Rickman, SCHULER, and WST, representatives from each of those companies that will be speaking today. We'll start the panel session with each of them presenting a very short piece on their company, some trends they're seeing, as well as a case study of how they have been able to demonstrate lightweighting that they want to share with us. So first, you can see my screen okay?
Sure can. Yep. Thanks, Adam.
You bet. Okay, so first I'd like to introduce Mr. Jason Steinbaum. Jason is responsible for engineering and technical sales in the US and Canada for EPOS. Jason works closely with customers and projects and engineers to integrate EPOS equipment into facilities that best improve ergonomics and operational efficiency. Mr. Steinbaum has a BS in ME, mechanical engineering, with a minor in business engineering technologies, both from Auburn University. For the past 4 years, he has been working on material handling systems with a special focus on overhead light crane systems. So with that, I will pass to you, Jason, and here's your introductory slide, Jason.
Good morning. Can everyone hear me okay?
Perfect.
All right, perfect. Yeah, I had a storm knock out my internet this morning, so that's why I'm having a little technical difficulties here, but thank you so much. And EPOS US is a German company. It was founded in Biel, Germany, but we've grown globally, and we are now across the globe in 13 subsidiaries, and the US is one of them. And so we have 6 different product lines, focusing mainly with ergonomics and material handling, whether it's load movement, manipulation of loads, overhead tooling, automation, or modular power systems, and also sanitation. As COVID, we've now adapted some of our products as well for sanitation purposes as well. And so some of the marketing trends that we've been seeing in the United States and also globally that we've had to tackle is really the online presence of companies and also the online tools. And so we've seen a lot of competitors and a lot of other companies in the market offering a lot of online tools and options because, as of course COVID's affected the nation, people are more online than ever. And so we've implemented some new tools online so that you can create your own crane system or create your own customized material handling solution online, something to bring the tools and products directly to the customer. We've also set ourselves apart by creating more robust products and more ergonomic products than the competitors. And a lot of people think that ergonomics and innovation comes with a price, but we've been very cost competitive in our market. And so we really believe that this sets us apart because we can offer innovation at a affordable price. And so the value that EPOS is bringing is, of course, the innovation, but also simplicity. All of our products are very universal and they all work together to accomplish the task. And we're also bringing a lot of new insights from other areas around the globe to the United States market. We've got a lot of experience in other countries that we're bringing to the United States, and it's really been helping our manufacturers here because they get to see how their partner companies or sister companies are doing it in other parts of the world and how they can improve over here. And so for our case study, this is a case study that a project we did in Germany for a company called EGO. It's an electric car manufacturer. And so we integrated some of our best product lines here in this facility. And so we have our crane systems, of course, for material handling. So we're moving large loads, very ergonomic. And so we have half the ergonomic push and pull forces as other competitors in the market. So we're doing very well with that. And then we also have a newer product called our Power Track and Base, which you can see here going down the line. It's able to store all of their power, all of their tools, all their screens in a very nice and organized manner. And so it's a way for them to not only make the facility easier to use, but a way to really make it more Industry 4.0 adaptable, so they can attach more and more technology and less cumbersome tools and conduit lines. And so I really believe EPOS is going to go towards the future with newer and newer innovation.
Excellent. Thanks so much, Jason. Our next panelist from Laubinger and Rickman is Philip Hettich, Head of Sales and Consulting for Laubinger and Rickman. Philip has over 20 years of experience working in and with the North American market. Philip is passionate about the field of non-destructive testing with a special interest in aluminum castings. He is member of the expert board of the German Society for Non-Destructive Testing and represents Laubinger and Rickman in the German Standardization Board. Philip's primary focus is leading the team at Laubinger and Rickman with customer engagement through the development of complete system solutions. Philip, please.
Thank you, Adam. Thank you very much generally for the organization, also to GACC. It's a very nice introduction. I actually should send you my CV so you could probably work over it. It's pretty good. Thank you. So I'm from Laubinger and Rickman. We're located in Münster, North Rhine-Westphalia in Germany, but selling worldwide. We basically are a special purpose machine company, as we classically say. We focus basically on material testing. That is one field where we build a very precise ultrasound mechanics, which are used for CFRP. I say mechanics because usually you have, for example, Kraut-Krämer or Vogt ultrasonic or different people who specialized on the ultrasound probes themselves. We build the mechanics around them, which, for example, in airplanes or wings for airplanes are used. So these machines are like 12 meters high and around 30-35 meters wide. But we also have like smaller plants that we build. We also have the so-called FPI or penetration testing plants, which are used in automotive industry, usually for chassis parts, which are safety relevant, where you basically put a fluorescent liquid on the casting part, you wash it off, and then you can see cracks and everything else by manual inspection. The other thing, and this is where I'm focusing on today a bit, is the straightening systems. So we use devices like the one you see in the background of my screen to put aluminum casting parts, usually HPDC parts, in shape in a fully automated way. And this refers to the trends that we see of these parts getting bigger and bigger, harder to handle. There was a lot of stuff in the media lately with the biggest presses in the world now. So these parts are getting almost impossible to straighten in a manual way. So you need a good automation. This is one thing we see. And at the same time, the request for dimensional accuracy increases all over. What we do a bit different than the rest of the market is basically our self-learning software, which we use in all these machines, which means we can adapt to various molds, to different material parameters in each part. Our software is learning, mostly with the DMC connection or with also other kind of recognizable parameters, so we can adapt our strategy. And generally, as I said, for the ultrasound, the precision is basically everything. What we bring to the US market, I think, is the same as also Jason mentioned before. It's just we're selling those machines internationally. We have them also already in the US. About 20 machines are located in the US right now. So, but we also learn from automotive industry and aerospace on a worldwide basis, and we try to bring this into the US market as well. Would be great if we can go next to the case study. Great, thank you. So this is one of those machines that I've just been talking about, used for a longitudinal member or Längsträger in German, made from HPDC. We have a low tolerance with plus minus 0.5, and we had cycle time limitations below 90 seconds for each part. There's a left and a right version always, so that's the one we can see the pair behind. The problem is you cannot do this manually because the torsion is very hard to do manually, and the forces needed are too high. And also we have to quite put a lot of force into it. We have more than 35 millimeters. We need to overstretch the part to do a constant shape change. And if you do it manually, you straighten in one area, the other one goes out. We call it the bucket effect. So you also need to work in all areas simultaneously. And you also need to consider the datum points. If the basis for your calculation is wrong from the start, then the end will fail. So that's what we all solve with this machine. And I think I sent you a video, if it will be possible, because I think it's a bit easier to see.
Yeah, I'm sorry, Philip, but we can't do the video at this time. We'll have to put it on the downloadable content or provide links for folks. Okay.
Then we do that. So what you would see is the important part, that we're able to straighten all drives independently in parallel. So we can move the whole part in different areas with different degrees. We can also decide where to put the torsion, if the center should be like in the middle of the part or on the left or on the right. And we can trigger them all at the same time or individually. And also the joining parts or joining points are later corrected manually. And this is all done below the 90 seconds.
Thank you so much, Philip. Really appreciate the introduction and this case study.
Thank you.
Now we'll move. Our next panelist is Paul Tom from SCHULER. Paul is the US and Canadian Market Sales Director for SCHULER's hydraulic product line of forming technologies. After studying industrial engineering at the University of Applied Science, Kaiserslautern in 2011, Paul worked for Hilti Deutschland as a sales representative. Afterwards, he graduated with a Master's of Science in Production Management in cooperation with Daimler Trucks. Fascinated by forming technologies, he started in 2013 at SCHULER Pressen as sales manager for hydraulic presses, responsible for hot stamping lines worldwide. In this role, Paul gained a lot of knowledge in lightweight technologies. In 2015, he moved over to the US as sales manager for hydraulic press systems to SCHULER's US subsidiary in Canton, Michigan. Since 2020, he is responsible as sales director hydraulics for the USA and Canada market with a strong focus on lightweighting applications. Paul?
Thank you very much for the nice introduction, Adam. That was great. If I look at my Swiss watch made in China, I think I have no time anymore. No, so yeah, I will make it very short. Thank you very much for organizing that, also to the Federal Ministry of Economic Affairs and also to GACC. And Adam, thank you for the introduction again. So yeah, so I'm located in Canton, Michigan. And to make it short, I mean, SCHULER is basically a press manufacturer. We do equipment. You see it on the left side. We do mainly any press that you can see in the market, hydroforming, hot stamping, so light, etc. Our big focus was always automotive. Since the crisis, 2009, we diversified much more, went into other industries, appliances, aerospace, etc. But the huge trend when it comes to stamping and compression molding, also composite stamping, is still automotive because of the volume. We see here and there also coming more and more heavy-duty trucks using compression molding. Again, we do stamping presses, so for us the market is not injection molding, it's compression molding when it comes to composites. We see at the moment also a big trend in the e-vehicle market. So a lot of compression molding projects are starting, especially for battery cases, for the body in white, etc. Our approach here is to understand the process. So we always try to see our customers from the perspective of their part. So we try to put ourselves into the shoe of the part. What happens to me? What does the machine have to do with me? Do I have to be cut, etc. So we approach it always with a turnkey approach to really understand the customer. We really want to understand the application, and then we build customized machines. So we do also automations. We do also or heating systems in the composite market. And for us, also the key here is service. So support the customer with lounge support, service, maintenance support, predictive maintenance applications. So we work a lot in the industrialization or industrialization, so industry 4.4 sector, 4.0. For us, service is very important. Service sales sells the first machine, service sells the second machine. For us, the US market is very important. I think it's in the last 5 years, it became the strongest market for US. We're growing a lot here in the US. So we are very happy to be here. To give you a quick case study, Adam, if you can switch to the next point here. So we did a composite compression molding project here. We are very happy that the Federal Ministry of Economic Affairs supported us. So thank you, Werner, to you and your team here. That was funded also by the government. So we're really happy with that. Basically, to make it short and shortcut the other slides, it's a project about putting a turnkey line in there, working with a lot of partners like Siemens, Teijin for the materials and others to put together a real turnkey line, self-learning line that from the first step, so from cutting the material to fiber spraying, and then forming the process until the quality check, collect all the data, and then lesson learned from each stroke. How can I reduce my material? How can I orient the fibers better? And in each stroke, we learn how to reduce basically the material cost, how to get faster, and how to increase the quality. At the end of the day, it's a self-learning cell. We just finished the project very successfully and happy to introduce in the future the new Industry 4.0 solution from SCHULER.
Excellent.
So I tried to make it short. Thank you very much, Adam.
Fabulous job, Paul. We're going to move on. And as people can see, there's a bunch of content that you wanted to share, and they'll be able to download that in follow-up emails. They'll get links to where they can download that content. So our next panelist is, you betcha. Our next panelist is Manuel Willman. Manuel is a member of the management board and in charge of business development and sales in the US for WST. Manuel's studies include a master's degree in business administration. He joined the family business 15 years ago and relocated to their new subsidiary in sunny California 2 years ago. So welcome, Manuel, and the floor is yours.
Thank you for the introduction. Good morning to you. As you can see in my background, we are from the Black Forest. So I just look at the watch. I'm 4 minutes already overdue, so I try to cut it short. The Black Forest that we are coming from, actually, you know the cuckoo clock, so that's pretty much the area that we are from. My great-grandfather and my grandfather, they were clockmakers. So this is like where in that area, the precision mechanics are coming from, clockmaking. Nowadays, we don't do any clocks anymore. As Paul mentioned, they're mostly made in China. So we focus more on CNC machining. So we are the experts in CNC machining. From process engineering, over manufacturing, quality, and shop floor management, continuous improvement. So our customers come from the automotive. We do business directly with OEMs, Porsche, Daimler, Volkswagen, and then with the tier ones, it's the Bosch, ThyssenKrupp, the Schaefflers. Also in aviation, Safran, Homed, and then like all other areas, automation, drive technology, medical defense, consumer goods, pretty much everywhere where high precision parts are needed. And we have the focus there on complex parts, complex materials. So basically, we don't want to do the easy stuff. The easy stuff everybody can do. And we have quite a lot of applications in the lightweight area. I'm going to later on show one example. We have 3 plants in Germany, and since 2018, our first subsidiary in the USA. So we're new here, but it's interesting, it's growing, and we want to also grow here. So as I said, family-run business. We have 578 employees currently. So there were like the 3 questions: what market trends are you seeing? Of course, nowadays, changing markets. I think, especially if you're in automotive, this is a lot of things are moving. So our thing is we want to stay flexible here. We want to be flexible because with every pandemic or everything that is with every crisis, there comes a chance. So we want to be flexible there. And we really what we see throughout the years, parts are getting more complex. You need to be more precise, more complex. So you also have to find innovative and new solutions. And leading over to the next one, what sets us apart? I think we really set on the newest machining technology. We have collaborations there with machine manufacturers. We do our in-house process development. We do our tooling ourselves. So we do special tooling ourselves. We have our own automation cells, so that we also do in-house. And We also have the passion for detail. I think it's also about people, that is quite important. And what we bring to the US market, we don't have our own product. So what we can do, we want to make your products better, price-wise, quality-wise, service-wise. That is what we can do. The company is not too old, so it's 25 years, and we went from 0 to 100 million. So we have a proven track record there. We can just see here one example. As I said, it's all about parts. So you see a aluminum part here, 52 millimeter diameter, it's 500,000. So this part is for an e-bike drive, actually, and especially right now during the pandemic, everybody wants to have their e-bikes. So we see really a lot of sales currently there. I still drive without e-drive. I think I'm turning 40 this year, but I still can do it without the e-drive. But it's interesting, and yeah, this part, we do it on a 13-axis machine, so it's complete high-speed machining. So you don't have second op, you have reduced cycle times and also reduced costs, which at the end, yeah, this is quite important. And also precision-wise, you can keep higher qualities. We are in the microns here. So we have higher qualities, a better product lifetime for the end customer. And the basics there, we want to make your products better. I guess
awesome. Man,
that was it in 3 minutes, 4 minutes. Yeah, thank you very much.
You crushed it. Great job, guys. Great job, everybody, for accommodating the tight time schedule. There's so many really interesting, innovative success stories that we've been talking about that we could go on and on for hours. Appreciate you compressing that into the time available. We've got some questions that are flowing in. The first question I'd like to share with the panel is about the role of hydroforming in lightweighting. So one of the attendees asked the question, the role of hydroforming in lightweighting. Jason, Philip, Paul, Tom, Manuel, who wants to take that one?
I mean, I take it.
Okay.
So hydroforming actually, I mean, what is hydroforming? You have a, let's say, a steel pipe, for example. You inject here water and form it while you inject the water. So you the part against, for example, a stamping press. So hydroforming is actually, you don't cut material out of the process, right? You're not reducing somehow the material. Also partially, in some degrees you form the material and it gets thinner in some areas, but it doesn't get lighter apart. But what you can do with hydroforming is, instead of, for example, welding several pipes together, you can really stretch material where you only need it in hydroforming. So at the end of the day, you can, for example, take an engine cradle. So in the engine bay, you can have, instead of 5, 6 heavy tubes that are welded together, you can really form a complex shape that has only material where required. Same like in additive manufacturing, you have try to have only material where it's required. So at the end of the day, you reduce really the material weight, the part weight. So at the end, lighter part, less CO2 emission, happy nature.
Awesome. So Paul, what I'm hearing you say is that hydroforming enables part integration in metals type applications that you traditionally wouldn't have thought of as being highly integrated or complex metal solutions.
Yes, exactly.
Awesome. So Philip, I see you like you want to comment on that, because I can imagine there's some non-destructive testing and some straightening and some things there that you want to speak to.
Yeah, hi, sure. Well, the non-destructive testing all depends where the crack comes from, right? So if you, in this case, if you would go for a hydroforming, I think the surface cracks would be the part is interesting. Is there anything left? Because it's full material that's bent. So the question is, where could be a crack on the surface where you probably have a radius or whatever else? So that would be a classical parent testing part, but usually we're talking about relatively low amount of parts destroyed by that, which is the big advantage of it.
Cool. So we have an enabling technology that delivers part integration, which drives down cost as well as reduces weight, because you've got this integral joining that's going on. And we have technologies available to monitor quality and ensure that we're able to optimize the lightweighting and deliver quality at the same time. Excellent. One of the other more broad questions that's come in is we see these case studies and the successes in lightweighting that you've been able to employ abroad. What's an insight or lessons learned that you could share with the audience on keys to successfully commercializing lightweight solutions? Who wants to take this one first? Manuel?
Yeah,
Well,
thank you. What we see is also here in our slides being one turn ahead. So you really want to be, you need to try new stuff. So you want to, it's something that it's interesting times, but you also need to be open for trying new stuff. So agile, as mentioned before, being open to try something new. That's pretty much it. New processes, try something new.
Not afraid to try new things. Excellent. Thanks, Manuel.
You will also make errors. So that we also have setbacks, and the more errors you make, the more you learn. That's pretty much the lesson learned. Yeah.
Excellent. Paul, did you want to say something? Did you want to add something here?
Yeah, I mean, for me, the key, I mean, I was actually on a panel discussion 5 years ago where the same question came up. And at that point, we were like all shocked. How can we enable this new technology? And it was compression molding, actually. That was just before we worked with IACME, actually, which is next to Lift. So, and thanks to Lift and IACME also for being actually what I want to tell you. You need enablers here, or how did Joe mention it, conveners. So you need people that you can collaborate with and present the technology. And what I learned in America is, in the US, is especially that you need to give appetizers to customers. So bring your technology over to a customer, work on collaboration, find a solution to show it to the market, and then utilize really the broad tools that are available here in the US, LinkedIn, I mean, YouTube, even Facebook, as I got here networking. And it's amazing how people are really sucking the information that you bring out into the market. And of course, talk with suppliers. If you have these enabler technology, US is very open for lessons learned, for learning. And so we have a press at IACME. I can tell you, so many customers went in there. IACME was very open. We appreciate that. Lift had also supported that. So that is one lesson learned, that you can really, show your technology in the US. It's very good to share the information about your technology in the US.
Thanks, Paul. And that ties in with both Werner's presentation earlier as well as Joe. You know, the platform for collaboration, the education and outreach, how all of you folks have these wonderful ideas, but it's critical that we get it out there to folks and get them involved working together. Philip, did you want to add something there?
Yeah, we could talk for hours about that, but it's so important because this standstill is not possible anymore. You know, we have a lot of industries that become a kind of, let's say, a bit lazy in many parts of the world, and it's so important to keep that speed up and to try new things, to go into developments with the customers together. I mean, Mr. Loschatter had the opportunities and the challenges of the lightweight industry, and they're worldwide, and they're all the same. And now Tesla is jumping in with the whole rear wagon, 1 part, 6,000 tons press. It's crazy technology. You have to keep up to keep the speed, to keep the pace.
Yeah, that is pretty impressive. One of the other trends that we see is when we talk about part integration, part size, that's come up a couple of times throughout the different presentations. So Jason, I can imagine the folks at EPOS are salivating at all the opportunities. While these parts might be lightweight, they can be rather massive. So how do we manipulate these parts? How does EPOS get involved and help enable folks? Any insights you can share as far as this dealing with these massive lightweight integrated parts?
Yeah, so we're normally using something we have called the Move L, and it basically we're using these types of move systems because a lot of times customers want automation, and so we're creating products to where these customers can move it manually, so it's much more cost effective. But we're able to move thousands of pounds manually, but also manipulate them, like turn them, rotate them, put them inside of another part, and really make it a more intricate process. So while you guys are creating the parts, we're moving the parts. And so it's a very interesting dynamic.
Awesome. Thanks so much, Jason. And thank you, panelists, for your participation and your support, the fabulous case studies. Brooke, I think we're ready to hand it back to you and get back on track.
Excellent. Yeah, I know we were a couple minutes behind schedule, so was not anticipating, Adam, you catching up so much for us, but thank you for keeping the time in mind. So first of all, if there are any questions for any of our panelists, as we have mentioned before, please feel free to put them in the chat and we will address them. There will be a few questions at the end that we have seen come in just about all presentations so far. So yeah, feel free to add those. Never too late to have your voice heard. So our next speaker, last but not least, is John Catterall. John is Vice President of the Automotive Program for the American Iron and Steel Institute, where he is responsible for leadership of the Automotive Applications Council, a group of member steel producers and automotive research, education, and technology transfer activities. John also coordinates the steel input to the Auto Steel Partnership, which has car company members including Fiat Chrysler, Ford Motor Company, and General Motors, and other steel-related consortia. John was formerly the executive director of the Auto Steel Partnership. In this role, he was responsible for maintaining and enhancing the partnership between auto and steel members and executing strategic projects to develop lightweight steel solutions to meet the current and future needs of automakers. He held this role from March of 2017 until March 1st of 2020. Previous experience includes the position of Global Innovations Manager for Body Stems at General Motors and Global Technical Lead for Chassis and later underbody structures. Prior to GM, his career experience has been in project execution, management, coordination, and technical leadership. John, the floor is yours. I think Adam you might have to stop sharing your screen.
Thank you.
No,
I should go ahead and be able to share my screen, I believe.
Yes, excuse me.
Let's make sure that works first. First things first. Okay.
Great.
Hopefully you can see my screen all right. Thanks a lot, Brooke, and thank you for the invitation today. As Brooke was reading that, you obviously realize I've been doing this for a long time now. I think I'm into 40 years, believe it or not. And I've actually been involved in lightweighting of vehicle structures for 30 years now. So I guess I've been at this game quite a long time now. So first thing I want to do is give you a background of the organizations that I'm involved in. I'll elaborate on what Brooke told you. So American Iron and Steel Institute has been around, it's over 100 years old organization. It now has members that are steel producers in the USA. I don't think anybody online today is an actual steel maker, but to be a member of AISI, you have to be producing steel in the United States. But what's important, and I've heard this a lot today, is the collaboration with the industry. And I think somebody truly correctly said it in the panel, to engage in North America, you need to get in direct contact with the OEMs, with the supply base, with the engineers. You have to go all the way to the engineers and you have to get involved with the purchasing as well as the engineers. So here are the organizations that I'm running and involved in. I actually run the automotive program for AISI right now. And it's focused on automotive. So the three key members are AK Steel Cliffs, ArcelorMittal, and Nucor. They're supplying sheet steel, and I'm going to focus mostly on sheet material today, but I'll do some comments about other material and processes as we move forward here as well. So you have to be a steel producer to be part of this. We commission material content studies. We've done one-on-one project directly with OEMs in the past. So that's what we do here. We then take these three steel companies, we add a couple more in, POSCO and Ternium. So now this is a North American entity. And Brooke mentioned we work with FCA, Ford, and General Motors. We also have created an affiliate program, and we have Martin Ray and Gestamp involved in the Auto Steel Partnership. Now, it's pre-competitive. It's based on research and development, but it's application. So it's more D than it is R. And we leverage all the intellectual property from these companies. We run project teams. We run actual technical projects. We have team members from these companies in the room doing the project. So that's where our intellectual power comes from. We also This is funded, these two organizations are funded by the members, but we also leverage funds from outside. We've leveraged funds Department of Energy before now, NSERC in Canada. We've worked with US CAR and US AMP, if people know what those are in the past. So we're funded by the members, but also we leverage additional funds. And last but not least, through AISI, we also participate in the World Auto Steel efforts, and that is all the world steel companies. And I've included the URLs to the sites here. If you go to the websites, you can also see all the social media. We now do a lot of our communication through social media. It's very efficient. And with us all being virtual now, it's almost essential. We can't talk about lightweighting without touching on the future. And here we think steel has a good role in electrified and future mobility. That's the autonomous vehicles. Through those organizations you saw on the previous page, steel has had a long success of partnering with its global automotive partners. Some of you may remember the ultralight steel auto body. That was in the mid-90s. I actually worked on that. And then future steel vehicle. And that wrapped up in the 2015 timeframe. So I've got some examples of lightweighting ideas that came from future steel vehicle and went into actual production vehicles. We've had a lot of success of our concepts, innovations, ideas, and materials getting into production vehicles, and that's what's key. Also, the electrified and future mobility will be no exception, and World Auto Steel is looking into what the future means for steel when it comes to electrified and future mobility. So just here's an example of, everybody thinks about lightweighting. They think about the lower dense materials that are out there, the aluminum and magnesium. But actually the majority of lightweighting in vehicles over the last 2 decades has actually occurred through the use of advanced high strength steels. It's just a numbers game. Most vehicles are steel dominated. There's lots of high volume, especially when you come to full size trucks. I'm talking specifically North America now, but you can see of all these vehicles here, major lightweighting over the last decade, and predominantly coming from steel usage is what occurred in these cases. So there's some big numbers. This has been a general trend in all of automotive anyway. Now, what I want to talk about next is more what is happening to lightweighting in metals in general, both in the next couple of years and moving forward. So what you see here, and I'm going to talk quite a bit around this chart, is it's a North American light vehicle material content share chart. Now, when we say light vehicles in North America, that's the small vehicles all the way up to the full-size trucks like the F-150 and the Silverado and the Ram truck. So it's quite a large span. And what this is, these are studies performed by Ducker Frontier. They've done studies for us in the steel industry. They also do it for the Aluminum Association. And they basically average, this is the average mass curb weight of a vehicle in North America. So it's averaging those small cars all the way up to the full-size truck. You could see it's 3,820 pounds. In the US, everybody continues to talk about pounds when it talks about material supply, because the supply base is set up in pounds. Just for those of you, obviously with the European background, 1,736 kilograms, which compared to the average vehicle in the rest of the world, that's quite large, but this is the reality in the US. You can see content split-wise, steel still remains dominant with the 52% share. You can see that aluminum is at 12%, so that's been growing mostly in the closures area. We still have a lot of iron, and this is because of those full-size trucks with the diesel engines, with rear differentials, things like that. So you can see predominantly. Now, you'll notice on here, if we talk about some of the other lightweight materials, magnesium, it's actually one of these slivers that's below 1%. Magnesium from a structural standpoint is really not taken off. There used to be a lot of instrument panel beams that were in magnesium. Those have reduced in number recently. And even if you look into the future, they're not predicting a big penetration of magnesium. You'll see a couple of examples. You've got the lift gate on the Pacifica from FCA, but it's not the major area where lightweighting appears to be occurring moving forward. In the metals, it's definitely focusing on the steels and the aluminum. So I'm going to focus on that. In the aluminum, they do have extrusions and castings. The shock towers are becoming very popular out of aluminum in a lot of vehicles, the front shock towers, and then extrusions. But there's actually a lot more sheet involved in this number than people would imagine. So there's been a big shift over to sheet usage in the aluminum market. So I just wanted to show you roughly the aluminum sheet offerings. Basically, you'll hear 5,000 series. That's typically a generic number is 5022. That's mainly for exterior panels. Then you'll have the 6,000 series, 6016. That's a lot of structural panels in the vehicle, mostly for stiffness and strength. These get tempered to a T4 or a T6. Some of that through the painting system does some of that tempering. Sometimes it's done, pre-going into the vehicle. And then the most recent introduction when it comes to aluminum, and these have been extrusions, and there's been some sheet as well, is the 7,000 series. A typical number is 775, and that is your high-strength structural panels. Now, this ends up with some welding issues, which is not a dissimilar issue that we have when it comes to the steels. So you can see the three main offerings in aluminium, as I would say. Now, when we move over to steel, you see that there's a much wider range of grades and offerings. And actually, I haven't listed all the different strengths. There's a number of strengths within these bands. There's over 200 sheet steel grades now available for automotive usage. So the advantage steel's been having is it's got these much broader range of offerings. Now, what happened with steels is as they went stronger and stronger, there was a loss of ductility. So the right side of this chart shows the loss of ductility. To handle that, then we got into the press hardened steels. So now you hot form those. That gives you the ability to make a complex part and still have the ultra high strength. However, in recent times, last 2 or 3 years, the retained austenites, which are actually the 3rd gen advanced high strength steels, have come online. And now that's an attempt to have a very high strength steel part, but be able to cold form. So you can see that lightweighting in steel is going to remain a force moving forward because it continues to produce products. And working with our customer base, they've told us they need these higher strength materials, but we still want to be able to cold form them moving forward. Now, as we introduce these steels, what we're doing through the consortia, and I would say this about the consortia that the steel company has working with our customers one-on-one, it's unparalleled by any other material. The Aluminum Association and Magnesium groups, they come together to promote their material, but they don't do a lot of technical projects one-on-one with their customer base. So that's what makes steel unique. So it's one thing having the materials, but what you have to do is help your customer base and your supply base apply those materials in manufacturing. So through the Auto Steel Partnership, that's where we do a lot of projects to work on formability and spring back, for example. So there's actually teams working at the ability to predict the spring back. So you have to have accurate material models to do that. And then what kind of measures can you have to basically reduce the amount of spring back you get in a part? It's no different than castings that the spring and need straightening. But what you can do in steel is you don't do any post correction. You do that actually in the dies themselves. So we've got a lot of work going on there. And then as you get to the richer chemistries of the high strength steels, during joining, which is predominantly spot welding in a lot of the car bodies, you can get liquid metal embrittlement. As you see here, you can form cracks in the metal. So we've actually got projects looking at testing the materials to see if they're susceptible to the LME, and then working on countermeasures to reduce the effect of LME. You get the liquid metal embrittlement when you have a coated material, which you need for automotive for corrosion protection. Just a couple of other things that they let you know the Auto Steel Partnership has been working on. They've also been working on mixed material joining. I heard that earlier. They did a study where they joined steel to aluminum. They're working on alternate joining systems, even to the point of maybe using self-piercing rivets to join the high-strength materials, because a fusion welding process can actually reduce the properties of materials. So perhaps a self-piercing rivet gives you a better joint at the end of the day. So I just want to say, while everybody's on the line here, if you've got a presence in North America, you can actually participate in Auto Steel Partnership projects. I know we've worked with press companies in the past. We've worked with supply base. So you can actually get involved in some of the projects directly. So if you have an interest, make sure you get in contact with me. And then moving forward, I just want to talk about some of the challenges that are going to come with these forward-looking vehicles and innovative vehicles. You've probably seen a lot of concepts that eliminate the B pillar, so you can get out of these autonomous vehicles and ride-sharing vehicles easier. That is going to present huge challenges of making this door ring very strong. We think that steel can do a good job of providing that strong safety cage around that door opening. Battery packaging, that's a big job for all materials. We've seen execution of battery packs in aluminum. We're seeing them in steel as well. They'll typically will go in the floor here. The challenges are that you cannot have any deformation of these battery packs, or the cells can become compromised. And that can lead to obviously loss of performance and perhaps even a thermal event, as we call it. And then moving forward, with these future vehicles, they're going after lightweight efficiently. And when I say efficient lightweighting, it's got to be cost effective as well. I think we heard that a couple of times this morning. Automotive is driven by cost. So if you can achieve your lightweighting goals through a lower cost application and a mass efficient and cost efficient application of steels, you might see a lot of companies doing that. They can then, with the money that's freed up, use that money to pay for the sensors, to pay for the more expensive battery packs. So the paying for lightweighting moving forward may not be as clear cut as it has been in the past, because you may be able to have a battery cell cheaper than paying for some of the lightweighting. So this concept of paying for lightweighting, which the OEMs never like to do in the first place, but it's going to be even harder moving forward to have them pay a premium to do lightweighting. So I think this is my last slide, Brooke. I think I did okay on timing.
Yes.
It would give us, so if you want to contact me, my contact information is here, and I think it's probably been supplied to everybody else as well, Brooke, right?
Yep, correct, yeah.
So I could take a couple of questions if any questions have come in, Brooke.
Yes, there are a couple questions. The first one is, what is your latest news on the new Steel International in Ohio? They wanted to build one of the most innovative and eco-friendly steel mills with many new technologies, including hydroforming.
Is that you're referring to the actual steel making itself, or them going downstream with the processing?
You know?
Both. So yeah, that question for me, John Paul here.
Yeah.
So both. So I know that they wanted to do the mill, and then they wanted to put in some new enabling technologies in there.
Yeah, so that is a trend in the whole industry. So the whole steel industry, they want to go towards carbon neutral. Okay. Mm-hmm. So the big push for steel moving forward is going to be, sustainability, energy efficiency, and they're going to want to move towards carbon neutral. Now, you're probably aware other material companies have tried to go up the supply chain as well by making tailor welded blanks, hydroform parts. It's happened in other materials like aluminum as well. It usually has like a 50-50 success rate. You're probably aware of this a little bit. ThyssenKrupp is another example of maybe going up the food chain, then pulling back.
Yeah,
because it's so difficult to be a material manufacturer and then start making those parts out of your material as well. Because when you set up that other division, they say, well, now I'm tied to getting my material from you, and maybe that's not my best business case for my customer. So it can work. It's definitely worked in the tailor-welded blank realm. Going much further than that, I guess they make pipe for the oil industry and stuff like that. But I jumped around a little bit there. But yeah, the steel industry wants to become carbon neutral, and then going up the food chain makes sense, but you can't go too far because I think you become locked into your specific company. I think that's the problem.
Okay, thank you.
Yes, thank you, John. I do have one other question. Do you see a breakthrough with Gen 3 steels versus boron steels and DP steels?
Yeah, we're already finding, actually in the last couple of months, we found that Ford has done an application of the 3rd gen advanced high strength steels in their new Bronco floor. And then GM's already also announced they've used it in the roof rail inner for their new full-size SUVs. So it looks like it's hitting the mark of being able to cold stamp some of these parts and not having to go to the additional expense of hot forming. Now, don't get me wrong in saying that hot forming is going to be replaced by 3rd gen. That's not the case. So it's given the automotive OEM another option, and they always like lots of options, and they will run the business case. It might be that in very large volume, very complex, say door ring inners and outers, you stay with the hot stamping, but maybe some of the smaller parts like B pillars and B pillar reinforcements, maybe they'll switch over to the 3rd gen because it's a better business case. And I've seen a couple of studies already where if you use the highest strength 3rd gen and replace the hot stamped B pillar, for example, the traditional 1300, 1500 megapascal, you get a very similar performance. Even though the 3rd gen is 1200 megapascals, it actually hardens rapidly when you impact it, and the retained austenite turns to martensite. So you actually can get a very similar result. So you're going to find, it won't happen overnight, but I think you're going to find a few of the PHS parts convert over to the 3rd gen, and our customers seem to be very happy about that.
Also, with the cost material versus boron steels, which are like simple farmer steels. Yeah,
well, we don't get into specific costs normally because we're pretty competitive, but so they are a little bit more expensive than the borons, but you're saving all the processing cost. So you've got to look at it. If you were just buying materials, you'd see a cost up, but if you look at the finished part cost, which is the total, material to, joining it into the vehicle, it is a lot less expensive. The boron picture was also complicated that there were some patents on the boron steels, so they were actually a little bit more expensive than the actual production costs, because there was they were protected. But now the boron steels have become more widely available. Now the patents have gone away. You'll also see the borons, the hot stamping companies get more efficient as well, and try and get closer to the cost of a cold stamp part. So competition's always good. The OEMs love that, right? So I think you'll see some cost efficiencies even on the hot stampers part to stay in the game. So I think somebody said it earlier, there's always innovation. We got to keep pushing the boundaries. This is another example of pushing the boundaries of innovation.
Thank you, John. I will contact you outside of there because I'm going to be quiet now. Too many questions from me. Thank you very much.
Yeah, get in contact. And like I said, SCHULER could even get involved in ASP if you were interested.
Perfect. Thank you so much, John, for the very, very insightful discussions. Definitely, I think a lot of us have been so deeply involved, not only this week, but, as obviously a lot of the bios have shown for such a long time about the industry, that it's so interesting to hear your expert opinion on where it's heading and how some of these disruptions in the automotive market are really transforming a lot of the technology. So thank you for your insights on that.
Yeah, no problem. I'll stop sharing now, right, Brooke?
Yeah, perfect.
Yep.
We do just have a couple questions actually that came in following some presentations. So a couple are for actually Joe at Lyft. If Joe, you still are on the line, I want to make sure.
I'm still here.
Yes, perfect. The first question is from connection to metals to composites is an item in the automotive manufacturing. Would it make sense to have textiles or preforms for composites with metal threads, for example, CF or GF fibers? They're also, this question is from Gerster Tex. They are also doing weaving of hybrid yarns of GF, PA together with aluminum or steel. So matrix is already woven in. If you could give a few insights into that question and what Lyft offers as solutions for that challenge or obstacle?
That is a great question and probably a better question for one of our technology folks. Unfortunately, that is above my my engineering pay grade. Again, we with IACME right next door with us, I'm sure there's a way that we can work together somewhere in our ecosystem. So I'd be happy to take that question specifically and follow up. Sorry about that, but I would love to bring our technology team in on that.
Yeah, I think definitely just having you as a resource, to connect to the correct contacts at Lyft is already a great starting point. There was another question regarding the joining forming of metal sheets with thermoplastic organo sheets, but I assume that also may have to go to an engineer.
I don't want to start making things up. So.
Sounds great.
But yeah.
Well, I see we just have 1 minute left. So for the sake of time, I think I don't see any other questions forming in. So I believe this concludes our event. Thank you all so much for your attention and for joining us today. If you would like to get in touch, you definitely have seen the contact information from all of our US and German speakers, but I will also be in contact with you with a platform where these presentations will be available, as well as a recording of today's event. Please stay in touch with us as we continue future events at the German-American Chambers of Commerce. You can go online to our websites and subscribe. I do want to highlight one additional event we have coming in December. We are bringing a delegation very similar to this in the field of autonomous driving, also to Michigan in a virtual format. So if you are involved in the automotive industry within this region, definitely feel free to subscribe to our newsletter to stay up to date on insights and information about that technology. So again, thank you so much for joining. I really appreciate your attention and the excellent collaborations. Well, we will be in touch with the contact information following this event, and I wish you a great day.
Bye, everybody.
Thank you very much. Bye-bye.
Thank you. Bye.
Thank you.
Thanks. Bye.
Bye-bye.